Okay, let's start. Okay. All right, so I'd like to thank Justine Kai Han for submitting your work. Giselle, I think you submitted, but somehow the portal does not give me your answers in the generated report. I just generated 2 minutes ago. All right, so question 1. We have 3 identical beakers. Identical means they're same size, same type of beakers. Beaker P, beaker Q, beaker R. They were all filled with equal amounts of water of different temperatures. All right. So you have water of different temperatures. Maybe some is room temperature water, some is hot water, some is cold water. Then the beakers were covered with identical lids. Lids means the covers, and placed on the table. And this table is inside a room with a temperature of 28 degrees Celsius. All right, so outside is 28 degrees Celsius air. Okay, so outside is all 28 degrees Celsius air. I'll just write here. And then they realized that there were water droplets on cup Q and R. So you can see that cup Q, there's water droplet here. Cup R, it's not clear, so I'm just drawing it. There are droplets, water droplets here. All right. So then the graph shows the change in temperature temperature of the water. Should be of the water. All right, temperature of the water inside the beaker. So you notice that here is time. As time goes by, can you tell me what happens to this temperature?
Decreases.
Decreases. So you can temperature drops. All right. So let me highlight this. Temperature drops. Okay. So you can see here temperature drops. Temperature of what? Can you tell me temperature of what? Is it temperature of the air around? The temperature of air in the room or what?
Room.
Temperature of?
Room.
Okay, then noted on your message. So can you tell me what is dropping? Temperature of what decreases?
Water.
Or drops? Water. All right. Water in the beaker. So temperature of water drops. All right. So over here, once you know this, can y'all, everyone, because not everyone has given me the answers, can you tell me which one tells you it contains cold water? Is it P, Q, or R? Can y'all type your answer into the chat? P, Q, or R? Which one contains cold water? All right, type into the chat. Which one contains cold water? Is it P, Q, or R? All right, which one is cold water inside the beaker? Which one contains cold water? Well done, Giselle. The rest? Okay, which one contains cold water? Jaslyn, Jia Ping, and Kaden, what's your answer? Which beaker inside contains cold water? Is it beaker P, beaker Q, or beaker R? All right, then well done, Kaden. How about Jaslyn, Jia Ping? Okay, well done, Jia Ping. Jaslyn, which beaker contains cold water? All right, so all of you, well done, all 4 of you. So inside here is definitely cold water. All right, it's only when you have cold water, then what happens is this air, the water vapor in the air here. So I'm going to write here, maybe I'll write here, water vapor in the air. All right. So water vapor in the air is very warm. All right, I'll write warmer water vapor in the air. It will touch the cooler surface of the beaker and it will lose heat and it will condense into water droplets. All right. So actually all these water droplets, it comes from the water vapor inside the air. So the water vapor in the air, because air is 28 degrees Celsius, then this is cold water. Imagine this is a 5 degrees Celsius water. All right. Okay, so imagine this is 5 degrees Celsius water. So if you compare 5 degrees Celsius cold water here compared to 28 degrees Celsius, 28 degrees Celsius will be higher temperature. 5 degrees Celsius cold water is a lower temperature. All right, so therefore the water vapor is considered warmer. So the warmer water vapor inside the air will touch the cooler surface of this beaker and it will lose heat to the cold water and the water vapor in the air will condense into water droplets. Outside is outside. All right. Then over here, can you tell me what is inside Q? Can you all type into the chat what is inside Q? Hi, Kai Han. Thank you for submitting your work. All right, can everybody type in the chat what kind of water is inside beaker Q? Room temperature water, hot water, or cold water? Okay, well done, Giselle. No, cold water, hot water, or room temperature water for beaker Q. Beaker Q. Well done, Jia Ping. All right, Kai Han, wrong concept. Okay, Kai Han now is correct. Okay, let me mark attendance for two of you. So I have Skylar and Kai Han. Just a minute. Okay, before I forget. No worries, Kai Han. You heard wrongly, it's okay. All right, so definitely here is hot water. All right, so this is hot water. So because it's hot water, what happens is there's air here. Inside this beaker, there's air. Of course, there's also air outside. So got air outside, got air inside. Now, the air inside has water vapor. Now, the water vapor here, at first is room temperature, but the water vapor here will gain heat from the hot water. All right, so the water vapor here will gain heat from the hot water, then water vapor becomes warmer water vapor. This warmer water vapor will then touch the cooler surface of the cover. All right, the cooler inner surface of the cover, it will lose heat and it will condense into water droplets. That's why you see water droplets here. So this is hot water. You see water droplets inside. This is cold water. You see water droplets outside. But please don't get the wrong idea that these water droplets is actually the cold water inside. No. All right, so these water droplets come from the water vapor. So the water vapor is a gas. It will condense into water liquid. Gas change to liquid. So water vapor in the air will change to liquid. All right. So please know this hot water, this cold water, and this is room temperature water because there's no water droplets inside. There's no water droplets outside. So my guess here will be this is water, which is 28 degrees Celsius, same temperature. This one, I can give any number, 90 degrees Celsius. This one maybe, all right, 5 degrees Celsius. Right, just anyhow give a number. So 5 degrees Celsius, smaller number than 28. 90 degrees Celsius, bigger number than 28. Here is 28 degrees Celsius water, same temperature. That's why there's no condensation. In order for condensation, there must be a temperature difference. All right, there must be temperature difference. Something must be warmer, something must be cooler. Then there will be condensation. So can you tell me which beaker will have the temperature of the water inside? The temperature drops. Can you type your answer into the chat? Which temperature of the water in which beaker will drop? The temperature of the water will drop, get lower and lower. Is it P, Q, R or Q and R? All right, well done, Kaden. All right, so which beaker will have the temperature of the water dropping as seen from the graph? All right, you can see from the graph, temperature dropping. So is it the temperature of the hot water will drop after some time, or will the temperature of the cold water drop after some time? All right, so well done, Kaden, Jia Ping. So the other 4 students, which beaker has a water temperature dropping after some time? Okay, well done, Kai Han. I have 3 correct answers. I have 6 of you. I'm waiting for the other 6. All right, Skylar, what is your answer? Okay, all right, now, the other 2. Jaslyn, what is your answer? Giselle, what is your answer? Only left 2 of you. Giselle and Jaslyn, what is your answer? Which beaker will have the temperature of the water dropping? All right. Now, Skylar, you opted for C. So you are saying beaker R. Now, this is beaker R, but this is cold water. Now, if this is cold water, after some time, right, this cold water, do you expect it to gain heat or lose heat? this is 5 degrees Celsius cold water. I anyhow give a number that's smaller than 28. Outside, the room temperature is 28. All right, if you're inside a room with a temperature of 28 degrees Celsius, so outside the beaker, 28 degrees Celsius. Inside the beaker, the cold water here is 5 degrees Celsius. So, Skylar, would you think that this cold water will gain heat or lose heat after some time? You imagine you put ice cold water on the table. What will happen to your ice cold water? Will it forever remain ice cold, or what will happen to its temperature? What will happen to the cold water temperature, Skylar? Gain the cold water will become warmer, gain heat. Good. All right. So the cold water after some time will gain heat. That's why the ice cold water on the table after some time it's not ice cold anymore. All right. So this temperature will go up. Temperature of the cold water here will go up. The temperature of the hot water will go down because hot water will not forever remain hot, right? If you put hot water on the table, hot water will lose heat to the surroundings. All right, so here the answer should be bigger Q because you see the graph temperature dropping. It will drop to room temperature. So this number has to be 28 degrees Celsius because outside is 28. So this hot water, if you put on the table, after some time, the temperature, let's say from 90 degrees Celsius, it will slowly drop to 90 to 80 to 70, 60, 50, all the way to 28 until it's the same number. All right. So let me write for you. The answer will be B. So here, this temperature, all right, this temperature is actually 28 degrees Celsius. Then this temperature is probably 90 degrees Celsius. I'm just giving you a number. All right, is everybody clear? All right, now Skylar, would you mind turning on your camera, please? Thank you. All right, let's move on. If you don't understand, please let me know you don't understand. It's okay, so that I can help you more. All right, nothing shameful about saying, oh, I don't understand. It's okay. All right, let's take a look here. Now imagine I have 2 beakers. All right, so I have this beaker plus the water inside. If I put on a weighing machine, it weighs 300 grams. So 300 grams is the mass of the beaker plus the mass of the water. All right, everything add up, the mass is 300 grams. So here I have the same volume of water, same size beaker, also 300 grams. The only difference is here is cold water. 5 degrees Celsius is cold. Here is hot water. 90 degrees Celsius is hot water. So that's why I put pink color. This is blue color. Because I know water is. What is the color of water, everyone? What's the color of water? If I ask you what's the color of water?
It's clear.
Cannot write clear. Clear is not a color.
No color.
No color, one word.
Transparent.
No, transparent is not a color. Colorless. Colorless. All right, I type it for you here. You say no color, right? No color is one word called colorless. Colorless is a color. All right, so you cannot tell me water is clear. Water is transparent. Wrong.
If you
clear, transparent. Now, Giselle, clear, transparent, they are not colors. So you have to write colorless. You need it for secondary school as well. So you learn the word colorless. So water is colorless. Please learn it today. Colorless means no color. Don't tell me color of water is clear. Wrong. Don't tell me color of water is transparent. Wrong. Clear is not a color. Transparent is not a color. All right. So colorless is a color. So here, both water are colorless, but I color it blue, I color it pink to show that this is cold water, this is hot water. Now, can y'all tell me, type into the chat, where will be the water droplets for the cold water? Side or inside? Imagine there's a cover, okay? So where is the condensed water droplets? Outside or inside? All right. Okay, well done, Giselle. The rest, outside the beaker or inside the beaker, where's the water droplets? Right, you notice that it will be here, right, outside. Okay, it will be water droplets because the water vapor in the air will touch the cooler surface of the beaker and it will condense. All right, then for the hot water here, the hot water, here the water vapor in the air is a gas. Water vapor is a gas in the air. It will gain heat from the hot water and then it becomes warmer water vapor. And this warmer water vapor will touch the cooler surface and it will condense. All right, this was what is shown here just now, right? Okay, just now you have hot